All right, we are in section 1.4 where we're going to be able to write equations and inequalities. Up to now, we've talked about equations. The definition that I gave in class for an equation is a math problem with an equal sign. The more general equation that you'll see in your textbooks is an equation is a comparison of two equal expressions. Now we said expressions were math problems without an equal sign. So two expressions together make an equation. An inequality is in a comparison of two unequal expressions. We'll talk about that in a little bit. And open sentences is an equation or inequality that contains an algebraic expression. Usually we have to use the verbal model to help us decode those open sentences. So if you look down here, we have ourselves various symbols. This first one we should really recognize, that is the equal sign. When we're in the verbal model, when we start to see word problems, anytime the word is used, that usually means that an equal sign will replace that when you write it as a math problem. When you have these values here, those are the inequalities. This one here is called greater than. Here is called less than. This one is greater than or equal to. And the last one here is less than or equal to. What makes it equal to those two bottom inequalities is that little bar below the inequality sign. So, like with the equal sign, I said is was a tell to show in any type of open sentences. When we look at greater than or equal or less than, some of the things you'll see is maybe for greater than would be like more than. That might be a tell. For less than, you could see fewer. When you see the term greater than or equal to, you could say at most. Depending on where this is located. And well, actually, no, I'm sorry. This one's would be at most. My apologies. Let me erase that. Oops. Close this off. Let me get the eraser. When we talk about greater than or equal to, we could say at least. Okay. So if you look at the bottom here, we were given some sentences, some phrases. These are open sentences. They want us to write the equation or inequality of the phrase, so we wanted to make it look like a math problem. So some of the things we talked about in previous sections, I believe it was section 1.3, where we talked about different things of verbal models with multiplication, division, addition, subtraction. So those things are going to tie into what we're going to talk about today, except not only are we going to have equal signs, but we're also going to have inequalities. We have, for example, A, the quotient of a 6 and a number K is fewer than 63. So quotient, we remember, is from division. So the quotient of 6 divided by K, and there say is fewer than 63. So I got 63. Fewer than that makes it less than. Okay. For B, it says the total of a number R and 15 is negative 18. Total came from addition. So I got R plus 15, and then I have the is, that means equal sign, negative 18. So R plus 18 equals negative 18. So for C, it says 4 less than the product of 5 and the number X is at most 31. So I go 4 less than, so that's subtraction. The product of is multiplication, so it's going to be 5 times X, and it's going to be at most 31. So this we said was an inequality, and it's going to be at most, which is less than or equal to, which is that what I wrote? Yes. Less than or equal to the result. And then for D, it's going to be the difference of 6 and the number W is at least negative 4 and at most 4. So you have ourselves 2 inequalities here. So this is a situation where you're going to have either 2 different equalities or you can combine them. So this is what it would kind of look like. So it would be 6 minus W, okay? And it's telling you it's going to be at least negative 4. So I'm going to put negative 4 over here. And I know it's going to be at least, so. And at the most, it's going to be 4. Because it can be negative 4. And it also can be 4, so it's in between those two. All right? The definition of solution is shown at the top. It's telling us that it's a value that can replace a variable and make an equation or inequality true. So how do we check? We evaluate. So we're going to be given these examples. You're going to tell whether negative 7 is a solution to the equation or the inequality. So what we're going to do is we're going to replace the variable x with our negative 7. So let's just solve accordingly. So I got a. So what I'm going to do is I'm going to replace that. So I got 6 minus, and I'm going to go parentheses, negative 7 is greater than 0. This is a cross the line, change the sign situation. So I got 6 plus 7, which is 13, and it's telling me it's less than 0. Is this a true statement? No, it is not. 13 is bigger than 0, so I'm going to say that this is not a solution. Okay, let's take a look at B. So B, I'm going to have 8 over negative 7 multiplied by 28 and see if it equals 32. So if I go, I'm just going to multiply across. First, I'm going to go 8 times 28, which gives me 224. And that's going to be divided by negative 7. I want to see if it equals a negative 32. 224 divided by negative 7 In fact is negative 32, so negative 32 equals negative 32. This statement is true. Okay. Looking at C, I have x is less than or equal to, or negative 3 is less than or equal to x plus 10, which is less than or equal to 3. So I'm going to plug in negative 7 in here, so I got negative 3 less than or equal to negative 7 plus 10, which is less than or equal to 3. I add this together, so I get negative 3, which is less than or equal to 3, which is less than or equal to 3. Is this true? Yes, it is. The reason why it's true is because of that bar underneath it. If that bar underneath it was not there, this would be a false statement. But since it is equal to, I can say that this is true. Last example in this section, I got x squared minus 20 is greater than or equal to 25. I'm going to put negative 7 squared minus 20 is greater than or equal to 25. Negative 7 squared is going to give me a positive 49 minus 20 is greater than or equal to 25. I do the operation of subtraction, which gives me 29 is greater than or equal to 25. Is this true? Yes, this is true. All right, we're going to finish off with some word problems. It's telling us that Sarah enrolled in a guitar class. The enrollment fee was $25. She paid the total of $70 for the enrollment fee in 3 sessions. What is the cost of the 3 sessions? How much did each session cost? Find the total cost for 8 sessions. So essentially they're asking us 3 things. They want to know how much 3 sessions cost, how much 1 session costs, and how much 8 sessions cost. So in order to do that, we need to find how much at least 1 session costs. So let's write out an equation to help us solve this. So on the left-hand side, let's just say I know that I'm going to pay $70 total, okay? All right, on the right-hand side, I know that of that $70, it came from a $25 enrollment fee plus 3 sessions. I don't know how much those sessions cost, so it's going to be 3 times the variable x. Whatever variable you choose to use, I choose x. So looking at this, this is just a regular solve for the variable equation. I'm going to subtract 25 to both sides, and I'm left with 3x on the right-hand side. 70 minus 25 gives me 45. To find what x is, I'm going to divide both sides by 3. X is going to equal 15. So essentially, I answered 2 questions. The first one is this one here. I asked how much do these sessions cost? That one cost $15. How much did 3 sessions cost? Well, all you have to do is take 15, multiply it by 3. Well, essentially that's $45, which we've kind of found that within the equation itself. And then the last thing, we need to find what 8 sessions cost. So I'm going to take that 15, multiply it by 8, and that is $120. So I got all 3 questions answered from that one equation. Okay. Let me get a little bit more room. There we go. All right, so excuse me, Jared is working at a retail store with a goal of grossing at least $390 a week between his wages and his commission. Every week he works 20 hours and makes $8 an hour. He makes a 15% commission on his total sales. If he makes $1,600 in sales, will he meet his goal? All right, so what I'm going to pay attention to is the first part with Jared. All right, so essentially, we know that he works 20 hours a week and he makes $8 an hour. So that's how much money he makes if he sells nothing. And then he gets a commission, a 15% commission. So it's going to be 15% as a decimal is going to be 0.15. And we want to know if he sells $1,600, is he going to be able to make at least 390? Now, at least is part of that inequality. Now, certainly he can make more than 390, so that means that the alligator has to open up here. But can he make 390? Yes, he can, so that's why the bar has to go there as well. So let's solve accordingly. Because of order of operation, we have to do 20 times 8 first, which gives you 160, and it's going to be plus, and then we have to take the multiplication of 1500ths and multiply it by 1600, which gives you 240, and see if it's greater than or equal to 390. So 160 plus 240 gives you 400, and is this in fact greater than or equal to 390? Yes, it is. So if Jared does make $1,600 worth in sales, he will meet his goal. Okay, and that is being able to write equations and inequalities. Hope this helps. Until next time.